Hi everyone, this video is going to be on further expansion, or as I lovingly call it, FOIL on steroids. It's because it's essentially based in what we do in FOIL, but it's taking FOIL to the next level. So, as I'm sure you are familiar at this point with FOIL, so FOIL is when you have two terms inside of two sets of brackets, and then essentially what you do is you take the first term and you multiply it by every term in the second, or this would be essentially the F and the O, first terms and then outer terms, and then the second term gets multiplied by both, or inner and last. So FOIL you should be familiar with by this point. So what happens though if it's not a binomial or two terms by two terms? What happens if, as seen in the example below, it's two terms by three terms? Or as we're going to see later, it's two terms by two terms by two terms, or some other kind of combination. Well, then we need what we call further expansion, which is essentially just FOIL, but more of it. So yes, we use an acronym for FOIL, but essentially you're taking the first term in the set of brackets and multiplying it by everything in the second set. Then you're taking the second term in the first set of brackets and multiplying it by everything in the second set. And that's exactly what you're going to do when you encounter a larger problem such as the one below. So we'll start by looking at the x, and then we're going to multiply that x by every term that exists in the second set of brackets. So 3 multiplications. So we start with x by x squared to give us x cubed, x by 2x plus 2x squared, x times 4 plus 4x. Then we're going to do exactly the same thing with the second term, which is the positive 3. We will multiply that by the 3 terms in the second set of brackets, and that will give us plus 3x squared plus 6x plus 12. So note, I had 2 terms in the first set of brackets and 3 terms in the second set of brackets. Note how many multiplications that required me to do. That required me to do 6 multiplications. So if I multiply the number of terms in the first set by the number of terms in the second set, I will get the total number of multiplications that I need to do. And FOIL is the same way, right? FOIL, you have 2 terms by 2 terms, so those are going to be 2 multiplications by 2 multiplications for 4 altogether. Then, of course, I need to simplify by collecting my like terms. Remember, we like to write these, we should write these in descending power of x. So I'm going to start with my x cubed piece, which is the largest power of x that I have. So I will write x cubed. There's no other x cubes to collect with it. Then I will go to my x squared terms, and I see a 2x squared there and a 3x squared term there. So 2x squared plus 3x squared gives me 5x squared. Moving down to my next term, which is my x term, so I've got 4x plus 6x to give me a total of 10x. And then last but not least, I have the plus 12, which doesn't have anything else to collect with it, so it just kind of hangs around and finishes off my expression. So that is how you do a question where you have 2 terms in the first set of brackets and 3 terms in the second set. So this idea of further expansion, this FOIL on steroids, can kind of carry over into other kinds of examples. So here we see 2, where we have an x out in front of an x plus 1 inside and another x plus 3. There's no way that I can do this in one step. Those are 2 separate multiplications, so I need to kind of deal with them one at a time. So I need to deal with this, and then whatever the answer is to this, then I will multiply it by my second set of brackets. So one piece at a time. So I'm going to start by just doing distributive law here, and so that gives me x squared plus x. This must remain in brackets because all of that then needs to get multiplied by the x plus 3 in the second set of brackets. So because I only have 2 terms in each set, this is a straightforward FOIL. So again, if you want to think about it, we're taking the first term, multiplying it by both in the second set of brackets, second term multiplied by both in the second set of brackets, or just standard FOIL. First gives me x to the power of 3, outer gives me 3x squared, inner gives me x squared, and last gives me 3x. Again, collect what I can. With FOIL, it's almost always going to be those middle two terms, and here it is again. I see both of those are x squared terms. Nothing else to collect with my x to the power of 3. 3x squared plus unwritten coefficient of 1 on that x squared, so 3x squared plus 1x squared, 4x squared, and then plus my 3x to finish off my final expression. Okay, so now moving over to other type, similar in that I can't do it all in one step. Different in that I have to do FOIL first instead of doing distributive law as I just previously did. So I'm going to start by doing this portion of my question. So I have to FOIL that out. So first gives me x squared, outer minus 3x, inner plus x, last minus 3. This needs to stay in a set of brackets, and I still need to multiply that by x plus 2. I could go ahead and just multiply everything in the first set by the second set, but I see that I've got a couple of like terms. So why not simplify, and then that means less multiplications to do down the road. So I'm going to simplify that. X squared, negative 3x plus unwritten coefficient of 1x, so negative 3 plus 1, negative 2x minus 3, that stays in a set of brackets. Still need to multiply that by x plus 2. So this is where the FOIL on steroids from the previous page kind of comes back again. So every term in that first set of brackets needs to multiply by every term in the second set of brackets, including this negative 3. That got really messy really fast. So here we go. First, we're going to start with the x squared, multiply it by x, gives me x cubed. X squared multiplied by 2 plus 2x squared. Move over to my negative 2 by each term in the second set of brackets. Minus 2x squared minus 4x. Move over to the negative 3. So negative 3 times x, negative 3x, negative 3 times 2, negative 6. So now we collect up everything we can, starting with our highest power of x, which in this case is x to the power of 3. No other x cubed terms, so x to the power of 3 stays as is. Moving over to my x squared terms, there are two of them. Plus 2x squared minus 2x squared means no 2x squared, 0 2x squared, so that term disappears. Move over to the next. Negative 4x minus 3x.